Let's now look at the activation function hard sigmoid. In the previous video, we looked at the sigmoid function, which looks like a nice smooth S-shaped curve. In comparison, the hard sigmoid has much sharper edges. It's not a smooth transition, and as we can see from minus 2.5, it's a sharp angle there, and right at plus 2.5 we see a sharp angle. Again, the setup is the same. On the left hand side we have the values of x. We can think of these as the input values for a neuron, which go from minus 10 to plus 10, and the neuron A this time is using the activation function hard sigmoid, which is shown up on the top right hand corner in the green box. The calculated values of A are shown in this column, and on the right hand side, as we know, this is the blue line, which is the activation function hard sigmoid, and the magenta colored dots are the values that are calculated here on the left hand side in the column A. Let's now look at the implementation in TensorFlow, or how we can use it in TensorFlow. The first thing we'll do is create the values for x and y. So let's do that. Hard sigmoid, that's what we are going to work now on. X is equal to tf dot linspace, and we want to go from minus 10 to plus 10, and we need 100 values. And y is going to be tf dot keras dot activations dot hard underscore sigmoid, so underscore sigmoid, and we have the values of x in there. Next, we need to simply plot these values. So we'll do plt dot plot x comma y, plt dot grid, and then we have plt dot show. So when we look at the plot, we should see that S, but it's much more sharper angles at plus and minus 2.5. Additionally, we could calculate the values as shown in the relation. We'll calculate values of y. So here we'll use the condition tf.where. Now, if the values of x are less than 2.5, less than minus 2.5, we return a value of 0. So values are set to 0. Else, if the values are greater than 2.5, so greater than plus 2.5, then what we want to do is return a value of 1. So it kind of plateaus there. Else, if the values are in between those two, then what we want to do is multiply the x with 2.5 and add 0.5 to that, and those are the values we have for y2. So we'll say plt dot plot x comma y2, and we should see an overlay which is right on top of the blue line, and that's what we have exactly, exact overlay of the blue line. So this is what we have for the hard sigmoid. Let's label this, and label is equal to hard underscore sigmoid, and the second one is the same thing. It's the label hard sigmoid. So we can again label this. This is just a calculated value that we have from the relation, and we can also create an overlay plot of the sigmoid function y sigmoid, and this is the regular sigmoid. tf.keras dot activations dot sigmoid, and that takes in the value of x. We calculate the value of sigmoid and plot it here. So we just replace this y by y underscore sigmoid, and we change this to just sigmoid. Now when we create the plots, we should see a nice S curve overlay on top of this. So probably made some typos. Yep, this should be sigmoid. Let's run this again. And as we can see, this is how the sigmoid looks like, the S shape in the green line, whereas where is the legend? That's what I was wondering. We have the legend, we can print the legend on the plot. And as we can see, the green is the sigmoid, which looks more curved as compared to the hard sigmoid, which has sharp angles. So that was how the sigmoid function, hard sigmoid function looks like, and also how it compares with the sigmoid function. We'll in next video we'll look at it another activation function. Until then, please like, share, and subscribe. Thank you.